All right, this is lesson 6-7, polygons in a coordinate plane. We're going to learn how to classify polygons in a coordinate plane. So we're going to use some ideas from that. First, we're going to be dealing with some irrational numbers here. So we need to review a little bit on how to simplify radicals. There's a couple things about simplifying radicals, a couple rules you can use, and you can look at these examples, but I'm going to write down these rules that you may use when simplifying radicals. All right, one thing you can do is this. If you have two radical expressions, like the square root of a times the square root of b, you can combine them under the radical symbol and just multiply them together. So an example of that would be something like this. The square root of 2 times the square root of 8 is equal to the square root of 16, which is 4. All right, another rule you can use is for division. You could say the square root of a divided by the square root of b is simply the square root of whatever a divided by b is. An example of using that would be something like this. So if I have the square root of 32 and I want to divide that by the square root of 2, I can just do 32 divided by 2 first, and I get the square root of 16, which is again 4. Okay, a couple things you cannot do when you're simplifying radicals. You can't add radical expressions together, combine them, or subtract them. And I'll just give you a quick example of that. Let's say I have the square root of 4, and maybe I have the square root of 16. I cannot say that that's the square root of 20. And just to show you that quickly, we know the square root of 4 is 2. We know the square root of 16 is 4. 2 plus 4 is 6. That definitely is not the square root of 20, because we know the square root of 6 is, the square root of 36 is actually equal to 6. So you can see that addition doesn't work. Neither does subtraction. So I'm going to do just a couple of these, and then you can go ahead and practice the rest. And if you want to check with me and see if your answers are right, you may do that. On this first one thing I could do is just combine it and make it the square root of 50. Now, a radical expression is simplified if it has no perfect square factors other than 1. And also the radicand cannot contain a fraction, and the denominator cannot contain a radical expression. So the one thing we got here on the square root of 50 is the square root of 50 has a perfect square factor, and that's the square root of 25. So I'm going to break that up into using that multiplication idea. I can write it as the square root of 25 times the square root of 2. And the square root of 25 is exactly 5. So in simplest radical form, square root of 5 times the square root of 10 is 5 times the square root of 2. All right, let's look at number 6. Square root of 36 divided by the square root of 3. Let's see, we can use the idea of division here. We can just say that this is just simply 36 divided by 3 under the radical, which is the square root of 12. Now the square root of 12 has a perfect square factor. Square root of 4 and the square root of 3 is equal to the square root of 12, and the square root of 4 is 2. So in simplest radical form, I would write the square root of 36 divided by the square root of 3 is 2 times the square root of 3. All right, number 11, 28 divided by the square root of 8. I'm going to write that like this. Now, one of the things that was said is that you cannot have a radical expression in the denominator, so we have to get rid of this, and that's called rationalizing. So we're going to we're going to multiply the numerator and denominator by a common factor that will get rid of the radical sign on the square root of 8. And the easiest way to do that is just to multiply by the square root of 8. But if you multiply the denominator by the square root of 8, to keep it in proportion, we need to multiply the numerator by the square root of 8 also. And see what happens. The square root of 8 times the square root of 8 is just 8, which is cool. Now there's no radical expression in the denominator. And then we have to simplify 28 times the square root of 8. If we want, we can simplify this fraction first. 28 eighths is the same as 14 fourths, which is the same as 7 halves. So we now have this. Now we have to look at this square root of 8, and square root of 8 has a perfect square factor of the square root of 4. So I'm going to write it as 7 times the square root of 4 times the square root of 2. And the square root of 4 is just the number 2. So I can multiply 2 times 7, which is 14. Square root of 2 over 2. And 14 over 2 is just 7. So I have 7 times the square root of 2. All right. Maybe I'll do one more. A couple more. Let's look at number 12. Square root of 300 divided by the square root of 5. Again, when you're doing division, you can just divide those out. So what I'm saying is this is really the same as this. And 300 divided by 5 is 60. So I have the square root of 60. Now the perfect square factor in the square root of 60 is 4. So I can write this as the square root of 4 times the square root of 15. And square root of 4 is 2. Square root of 15, 15 has no perfect square factors. Its factors 3 and 5 are not perfect squares, so that's in simplest radical form, 2 times the square root of 15. All right, I'll let you go ahead and try and do the rest of them. And we'll move on with the lesson. Review, draw a line from each item in column A to the corresponding parts in the coordinate plane in column B. Go ahead if you want to pause and check back, see if you remember these parts. That'd be cool. This section over here is quadrant 1, quadrant 2, quadrant 3, quadrant 4. The x-axis, the origin is right here. X-axis is this one. Y-axis is this one. I think I'm going to skip that. And just a couple formulas we may be using here to help us prove in the coordinate plane. We're going to use the distance formula. So that's to determine whether sides are congruent. We can just show that they both have the same length. Or if diagonals are congruent. Midpoint. Help us find the coordinates of the midpoint of the side. Help see whether diagonals bisect each other, and the slope formula to determine whether opposite sides are parallel, whether the diagonals are perpendicular, whether the sides are perpendicular. So number 5, you want to know whether diagonals bisect each other. That would probably be the midpoint formula. If you want to find whether opposite sides of quadrilateral are parallel, that would be the slope formula. If you want to know whether sides of a polygon are congruent, that would be the distance formula. All right, so let's go ahead and use some of these. Problem 1, we want to classify this triangle as either scalene, isosceles, or equilateral. To do that, we really need to know the length of the sides. So let's label a couple points here and then use those points. R, we use these coordinates. R is -4, 1. S is 3, 3. And T is 1, negative 3. And then we're going to use the distance formula here to find the distance from one point to another. Now, if just thinking about this, the distance from point R to point S is just the difference between the x coordinates horizontally and the difference between the y coordinates vertically. So RS is equal to, and the square, I'm going to just skip to the part where we square it, but the horizontal distance between R and S is the difference between the x coordinates. So from -4 to 3 is 7 units. And you get that by subtracting those 3 minus -4, or -4 minus 3. One way you get positive and one way you get negative, but when you square it, you're going to get positive anyway. Then we're going to add the vertical distance between R and S, which is 3 minus 1, or 1 minus 3, which is 2 squared. And if I simplify that, I have 49 plus 4, which is the square root of 53. And that's in simplest radical form. So ST, do the same thing. The horizontal distance between S and T is the distance between 3 and 1. 3 minus 1 is 2, so we're going to do 2 squared. And then the vertical distance between is the difference between 3 and -3, which is 3 minus -3, which is 6 squared. And so I have 36 and 4, which is square root of 40. And I can simplify that, but I'm not sure I need to simplify that unless I can't tell if my radical expressions are the same. So I'm just going to leave it unsimplified. RT is equal to the horizontal distance between R and T is the difference between the x coordinates. -4 minus 1 is -5, or we can just do 5 squared since we're squaring it. And then the vertical distance is from -3 to 1, which is -3 minus 1 is -4, or positive 4 squared. And 5 squared is 25, plus 16 is 41. And these two lengths are really close, but they're not exactly the same. So we can see that all three lengths are different. So we're going to say this is a scalene triangle. And our proof is all three sides are different lengths. Go ahead, you try problem 1. See if you can use the distance formula there to help to classify that triangle. Again, we have a scalene triangle because three sides are different lengths. All right, I'm going to stop this video now. We're going to have to do a second part.